This is the prep packet video for Unit 4, Chapter 9.6. We're looking at objective number 1, and this is the first video for this one, part 1. And we're going to be rationalizing a denominator with one square root. Before we start, I want you to think about the idea of changing denominators from one thing to another. And remember that you have a lot of experience doing that from working with fractions. So if I had a fraction like 1/3 and I needed to change it so that it was in terms of 15ths. Basically what I'm doing is I'm taking the original fraction and I'm disguising it. For instance, if I dressed myself up as Santa, I would still be me. I'm just dressed up. So what we're doing with the fraction is we're dressing it up as well. 1/3, to get from 3 to 15, I need to multiply by 5. And what I do to the denominator, I'm going to do to the numerator. So my new dressed up version of 1/3 is 5/15. We do the same thing when we have radicals in the denominator. So if I had 2 over the square root of 3, mathematicians and other people who use this say you mustn't have a radical in the denominator, so you have to make it go away. And just like I dressed myself up as Santa, I'm going to dress this up too. I'm going to multiply this by itself, because my goal is to get this to a whole number, right? And what I do to the bottom, I have to do to the top. So think about it for a second. The square root of 3 times the square root of 3 would be the square root of 9, and 2 times the square root of 3, because multiplication goes across. That's going to stay the same. But the square root of 9 is, 3. And that works out because the square root of 3 times the square root of 3 is 3. And what I've done here is I have rationalized the denominator. And here it is in black and white. The process of eliminating radicals from the denominator of an expression is called rationalizing the denominator. And again, let's try it here. So here we have 1 over the square root of 3. The square root of 3 here is a big no-no. So what do I have to multiply that to get a whole number? Well, the square root of 3. And what I do to the bottom, I have to do to the top. So now I'm going to multiply across, and I'll end up with the square root of 3 over 3. I can't reduce that, tempting though it may be. Here I have 36 over the square root of 18. I'm going to multiply this by the square root of 18 and the square root of 18, because that's secretly 1, right? That's just dressing it up. So my new improved version looks like this. 36 times the square root of 18 over 18. The square root of 18 times the square root of 18 equals 18. I can do some fancy reducing here, and I'll have 2 times the square root of 18. Now, before you get excited and want to move on, remember I can factor some stuff out of this. So this is really the square root of 9 times 2, right? Can I pull a square root out of that? You betcha. Out comes a 3. So my new version is 2 times 3 times the square root of 2, or 6 root 2. Same thing here. I have 5 times the square root of 3 times the square root of 2 over the square root of 2 times the square root of 2. Together, this is the square root of 4, or just plain 2. And up here I have 5 times the square root of 3 times 2 is 6. These are both prime numbers, so 6 doesn't have any hidden squares in it. And I can't reduce 2 and 5, so I'm good here. Here's another pair. If they have a variable in the denominator, you handle it exactly the same way. So this is 2 over the square root of x times the square root of x over the square root of x, because together those will make a whole, right? So now I have 2 times the square root of x over just plain x. If you want to think of it this way, it's the square root of x squared. And remember from before, this cancels out and just leaves behind the x. Same thing going on over here. And what I also want you to think about when you have this rational radical like this, remember that you should try to simplify first. And here actually we can't, but it was a good thought. So here I have the square root of 12m to the third over the square root of 7n. If I multiply them both by the 7n, the square root of 7n, my new and improved version looks like this. It's 12 times 7 is 84, and 84 contains no perfect squares. M to the third n all over 7n, because remember this was the same as the square root of 7n squared, and that comes out. So the only thing I could reduce here is this. So remember that's a secret 2. 2 goes into 3 one time, so m gets to come out and leaves behind an 1m. So my new version looks like this: 84 mn over 7n. And I know it's tempting to do some canceling here, but because those are trapped inside the radical, you can't touch them. Here's another one. And again, I have the square root of a rational expression, the square root of a fraction. I'm going to try to reduce first. So here's a c and here's a c, so they canceled out. And with the d's, I have 2 and 3, so that would be the same as d to the 2 minus 3 equals d to the negative 1. So that'll leave behind a d there. So now I have it's a little easier to work with, right? Because now it's just 6 over d, all under the square root. I took it apart, and now I'm going to multiply it by, I'm going to rationalize the denominator by multiplying it by whatever it takes to get to a whole number. So now I have the square root of 6d over d. And that was a lot easier because I did all my canceling before I got started. And that's it for part 1. Go ahead and stop and copy, and then we'll see you for part 2.